right, so we're going to look at another classification of sequences and series. So again, those words, sequence and series, easy to confuse. They both start and end with S's. They're both taught kind of simultaneously or really close to one another. We want to be careful. Conceptually, right, they are different. Sequences are lists of numbers separated by commas, right? Series, you take your sequence, and what do you do with that sequence to get a series? Add them up. Add up the terms, okay? Add up the terms. So we're going to start with introducing just the geometric sequence, just like we started with introducing arithmetic sequence. Okay. So a geometric sequence is a sequence of numbers okay, where the ratio of consecutive terms is the same. The ratio of consecutive terms is the same. And that same ratio that you use over and over and over again is called the common ratio, right? So we'll talk about that here in just a second. Just like we had a common difference, right? Common ratio. So here's an example of a geometric sequence. 2, 6, 18, 54, and, dot, dot, dot. Okay. What is our common ratio here? Okay. Yes, times by 3, right? The common ratio here is 3. Okay, how did you get that, James?
I just did 2 times 3 is 6, 6 times 3 is 18.
That's right. Okay, so that's one way. Sometimes we can kind of just look at it and see, okay, 2 times 3 gives us 6, 6 times 3 gives us 18, 18 times 3 gives us 54. Okay? However, if we kind of get stuck, right, sometimes we may look at two numbers and we might be like, I'm not really sure what I multiplied the first one by to get the second one, right? Sometimes it's not so obvious. So what you could do then, alternatively, right, is actually do what the definition here says. The ratio of consecutive terms is the same. So that means 6 over 2 is equal to 18 over 6 is equal to 54 over 18, which is all equal to 3. And that's how you can find your common ratio that way too. Just take the next term, divide it by the previous term, and that'll give you your common ratio as well. Okay, in case you're like not sure about what to multiply by. Okay, so the nth term of a geometric sequence. So again, just like we had for arithmetic sequence, we had to find an nth term, right? We can also do the same thing. The nth term of a geometric sequence okay. So we're going to try and find that a sub n, the nth term of the geometric sequence. Okay, notice there's no difference, right? A sub n, that's still used to describe the nth term. So if A does not stand for arithmetic or like G for geometric, no, we use A sub n in both cases. Okay, so don't get that confused either. We use A sub n because we're talking about the number of the term, or the term, the certain term. Okay, A sub n equals your first term. Okay, your first term, and it's going to be times, right? Because we multiply over and over again here, and it's going to be the common ratio to the n minus 1 power. That's it. Okay, so A sub n stands for the nth term. A sub 1 stands for the first term. R is that common ratio. And then n is the number of the term. Okay. All right, so let's just, do an example here. So let's write out the first 5 terms of the geometric, I'm just going to abbreviate that with geo, the geo sequence, and I'm going to abbreviate that too. Okay. With a sub 1 equal to 3 and r equal to 2. A sub 1 is 3 and r equals 2. Okay. So if I wanted to, we could write out the formula for the nth term of the geometric sequence here. So I could say a sub n equals, okay, what's going to be our next number here? A sub n equals what? 3, yep, times what? 2 to the n minus 1, right, because we don't know our number of our terms just yet here. So there's the sequence formula, okay? But of course, this might be kind of overkill too, because, well, we know when our first term is 3, and if our common ratio is 2, what's the next term got to be? It's got to be 6, right? Just 3 times 2. And then what's the next term going to be? 12, right? And then 24, and then 48, and then we're done because we have the first 5 terms. Okay. But alternatively, you could, plug in. So this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5 there. You could plug those in, right? Let me just, as an example here, let's plug in like 4. 4 minus 1. 4 minus 1 is 3. 2 to the third is 8 times 3 does give us 24 there. Okay, so you can see it works. And it'll work for all the other ones there too. Okay. Okay. Here's one for you guys to try real quick, and then we'll move on to the series. Find the 15th term of a geosequence whose first term is 20 and r equals 1.05. Okay. Let's go ahead and take like 30 seconds. Figure that out. And you may use calculators for this, please. And I would say round to like 3 decimal places. Oops. There we go. Okay. There should be our answer there. Okay. I originally made a mistake here, so I scratched it out. Okay. I accidentally tried to find the 20th term. So there's lots of numbers flying around here. Just make sure you're putting the right number in the right spot. Okay. 39.599, approximately. Right. Questions on any of that? Okay. Cool. So let's get into some series then, okay? We learned one new formula. I told you we're learning 3 new ones today, though. So let me show you the first, or the next one then, the second of the 3 that we're learning now. Okay. First, we're going to look at a finite, finite geometric series, right? As opposed to infinite, finite means it's n, infinite. Notice we don't have that designation for our arithmetic series, right? We just say arithmetic series. But you could call this arithmetic series a finite arithmetic series, right? Because for this to be able to add up, for us to be able to do this, it has to be a finite number of numbers, right? We have to have a starting point and a stopping point here. Same idea for this one, okay? We don't put the finite here, but we could call this a finite arithmetic series, just like we're calling this one a finite geometric series. We're going to add up a finite or a limited number of numbers here. Okay? And again, this formula you will be given. The sum, okay, is the first term times 1 minus r to n over 1 minus r. Okay. Please make sure you use good parentheses here too, especially with this fraction. Okay, so you need to have parentheses around your numerator and parentheses around your denominator there. Okay, otherwise you'll mess your calculations up. All right, otherwise you'll mess them up. So again, the S stands for the sum. A sub 1 stands for the first term of that geosequence. R stands for the common ratio in both cases here. And then N, of course, stands for the number of terms. All right, so let's evaluate some finite geometric series here. Oh yeah, there's that sigma showing up again. I know you missed it. I know you did. Okay. So first of all, how do we know that this is a finite sum? We know it's a sum, right? It's got the sigma there, and we hopefully know that means sum, right? Okay. How do we know it's going to be finite? A finite number of things. What clues us in just by looking at what we've got right there? What clues us in? Yeah, right. It goes only up to 8. That's exactly right. From 1 to 8. I know 8 looks like an infinity symbol on its side, but it's 1 to 8. Okay. So it's a finite number of numbers. All right. How do you know this is geometric? Well, it might not be so obvious. I mean, of course, it would be kind of cruel of me to just, put this under a finite geometric series when it's not, if it's not geometric. It is geometric, but how can we tell? Well, let's take a look at some of the first couple numbers here to see what's going on, okay? What will our first term here be? What will our first term be here? All right, let me ask an easier question. Where does n start? 1. If I put 1 in for n, what's the value going to be? 0.3. So that's our first term. Okay. Then if we do n equals 2, okay, 0.09, 0.09. Okay, which is really what? 0.3, if I multiply by another 0.3, gives me 0.09. And then the next one, n equals 3, is going to be, again, I can put the 3 in here. It's going to be 0.3 times 0.3 times 0.3, okay, 0.3 times 0.3 times 0.3, which ends up being, I think, 0.0027. I think that's right. Okay. And then we can just say, okay, so on and so forth, all the way up to, and then I'll just go ahead and do the n equals 8 as well here. Okay, which is, and I'm just going to do that in the calculator here. Ooh, okay, I'll write this out, but you don't need to worry about writing this out. Okay, it's like a scientific notation. The calculator doesn't even want to write it out. Okay? Now, the good news about a finite geometric series, okay, unlike the arithmetic series, okay, we only need to know the first term in the finite geometric series. Notice there's no a sub n in here at all. Whereas in arithmetic series, you have to know the first term and the last term there. I don't have a cool story, and some of you guys might be thinking, yeah, this would be cool in air quotes. But I don't have a cool story for the geometric series like I did for the arithmetic series. There's no like legend about that I know of, at least. So maybe there is, but I don't know it. But anyway, the nice thing about the finite geometric, you only need to know the first term and then the common ratio. That's it. Unlike the arithmetic, where you have to know the first and last term. So it's a little bit nicer. So let's go ahead and set this up. So the sum is going to equal, okay, what's a sub 1 in our case? 0.3 times 1 minus, what's our common ratio here? What are we multiplying by each time? 0.3, yeah, so it's 1 minus 0.3 to the 8th over 1 minus 0.3. Okay, so you guys go ahead and type this in your calculators. Okay, and I really strongly suggest you try and type this in your calculator just to make sure you can type it in correctly. Okay, because some people will type this in incorrectly. And again, let's round to 3 decimal places. Let's round to 3 decimal places here. Actually, let's do it up here. Okay. So I did this 3 different ways. One of these answers is correct. Only one of them. Obviously, because they're all different. Okay? So, this one is not correct. So if you got that answer, you rounded wrong. Or not rounded wrong, sorry. You rounded correctly, but you did the wrong, you set up and calculated incorrectly. Okay? So that one's wrong. And this one's wrong. Okay. So, how do we type this in our calculator accurately? Mr. Witt, I can do the math, I can set it up, but I can't use this piece of technology. Okay, so let me show you. All right, if you got 0.209980317, if that's what you got, I'm going to highlight up here. Okay, what's the error that I made here? Okay, no parentheses around the 0.3. And what else is the problem here? What's getting divided by what, according to this? I think the calculator is going to do 0.3 to the 8th and then just divide it by 1. And that's it. We don't want to just do 0.3 to the 8th and divide by 1. We want to do 0.3 to the 8th. We want to do 1 minus 0.3 to the 8th, that quantity, then divided by the quantity, 1 minus 0.3. So this one's wrong in a couple ways, okay? I think you can get away without putting the parentheses on the 0.3 like that, but you do need to put an extra set of parentheses on the numerator and an extra set of parentheses on the denominator. Okay? All right? Let's go on to the next one here. All right. Here I did put the parentheses around the point 3. I did put parentheses around the denominator. I did not put parentheses around the numerator. And I got the wrong answer again. Okay. Here then for the last one. Okay. Parentheses on the numerator, parentheses on the denominator, and then a general set of parentheses there. I think you can get away without having to do this extra set of parentheses there. I think so. It should be okay. Okay. But again, I put them there just because they're there in the problem. Okay. But it is 0.429. Okay. So again, make sure you're able to use that piece of technology you got there to set those up. So, with that being the case, I want you guys to try one here, and let's see if we can fix the error of our ways. Okay. Let's see if we can fix things here. Okay, I'll give you another problem in sigma notation. Okay, so there's the sum. Looks a little bit different than that last one, right? So I suggest you write out a couple, the first couple terms so you can kind of try and figure out what's going on, okay, with this, because I know we're not so comfortable with this. I say write out at least the first two terms, and then try and find the sum here from 1 to 12. Okay, and hopefully I didn't make this too big. That could be a issue. I'll freeze like that. You got a lot of pieces to find out, right? You got to figure out what that first term is, got to figure out what that common ratio is, and then you got to accurately type in your calculator to get that correct sum. Okay, I'll be happy to look at your calculator, or happy to look at your answers, something like that. If you feel like you want to, just check to make sure it's right. We can do that. Yes, that's it. Good job. Yeah, good job, baby. Well done.
So what's now? Is it time for the parentheses now? Good.
What's your answer here?
So hopefully I have the sense to like compare. See, I got 8. Got less than 1.
Yes.
Ooh, 18.4. Big number. 10. Big, big.
So n
Like,
starts at 1. So
like,
we do 1 minus 1, which is 0.
oh,
3
sorry,
to the 0 is 1. So what do you put for your first term?
start with a 9.
But then n equals 2. 2 minus
Could you,
1 is
can you
1.
do 4?
3 to the 1 is 3 times 4 should not be 32. It should be 12.
So what you have right here, don't you put 10?
Yes.
4. 4, so what you have? Write out,
Start calculating
write out,
that.
yeah, write out my first 2, like,
Do you want to borrow a calculator?
yes, let's do the ratio.
Anyone else need to borrow calculators? Anyone else?
I wrote it
Was
out
it G
first
one?
to you. So yeah.
Well, I'll give one here too. You're welcome.
What do you do?
good. Yeah, unfortunately these things get like way out of control. Yep. Because you're multiplying and then you're adding those those things are then multiplying and getting bigger and bigger, so it's like the numbers get kind of crazy. Okay. All right. So there's your work. There's what I would, again, my work that I kind of used here. All right. I found the first term, 4 times 3 to the 0, which is 4. 4 times 3 to the 1, 12. 4 times 3 to the 2, 36. Okay. And maybe you aren't writing it out like I am here. I'm taking it very step by step. I'm plugging in. Start with 1. 1 minus 1 gives me 0. And then do 2. 2 minus 1 gives me 1. And then 3. 3 minus 1 gives me 2. And then I'm doing the math one more step down here. Okay. Take as many steps as you need here. If you find yourself making mistakes in these numbers, then you need to do more steps. You need to take more steps, okay, to get there. Anyway, we can see our first term is 4, common ratio is 3, and so then we've got our formula right here. And then the last challenging step is making sure we type it in accurately. And then there should be your final answer, 1,062,880. Okay. You'll notice here that I did not put an extra set of parentheses around the numerator, around the entire fraction, and I was able to get away with that. Okay, it does work, and it should be okay for you to not have to put an extra set of parentheses. So really, you just need to make sure you have a set of parentheses on your numerator, divide by a set of parentheses on your denominator, and you should be good to go. But that's your final answer there. Okay. Questions on any of that? All right, I've got one more formula I got to show you here. One more formula. Okay, and that is the infinite geometric series. Infinite geometric series. Okay. You'll notice here that we do not have a formula for infinite arithmetic series. Okay, and we kind of talked about this some yesterday, I think, but if you were to add an infinite number of numbers who have a common difference, that are like increasingly getting larger or increasingly getting more and more negative, because that's the way it's going to go. Either you're going to keep adding up to get more and more positive, or you're going to keep subtracting kind of to get more and more negative. If you add an infinite number of things, turns out that they're going to be infinity or negative infinity, depending here. But there is a scenario here. There are some scenarios where you can add up an infinite number of geometric of an infinite geometric sequence, and that sum will be finite. Okay? So let me show you the formula here. The sum of an infinite geometric series is equal to a sub 1 over 1 minus r. Okay? So that is how you can add up an infinite number of things and get a finite sum. Now, there's a very important caveat here, right? When the absolute value of the common ratio is less than 1. Okay? So, in other words, you cannot take the sum of an infinite number of things, just kind of a random assortment of any sort of geometric sequence. You can't just add up, okay, and all of them and get a sum. It only happens when our common ratio is less than 1. Now let's think about that. If the absolute value of our common ratio is less than 1. If the absolute value of our common ratio is less than 1, that means it's going to be what? If we're less than 1, what kind of value is that? Like, what? Decimal, right? And of course the decimal that's less than 1. It's like 0.5, 0.3. And so if you think about it, okay, as you repeatedly multiply something by 0.3 or 0.5, let's just say 1/2 for the sake of 1/2. As you repeatedly multiply something by 1/2, the value of that thing is going to get smaller and smaller and smaller. Yes, we're adding them all together, an infinite number of things together, but the values are going to get smaller and smaller and smaller and smaller, and so small to the point where we can finally get a finite sum there. Okay, it's basically the idea behind that. Okay, if r is not less than 1, so in other words, otherwise, the sum approaches infinity or negative infinity. Okay, so in other words, you might be asked to add up an infinite number of things in a geometric series, but if the absolute value of r is not less than 1, the sum just goes to infinity, right? It just keeps getting bigger, it goes out of control. So you wouldn't be able to find the sum. Okay. So let's find the sum of the geometric sequence 500, 300, 180, okay. Okay. What's the common ratio here? 3/5. How'd you get that? Just by looking at it? Okay. We can also take the second term here, 300 divided by 500, simplifies to 3/5. 180 divided by 300 also simplifies to 3/5 here. So yes, the common ratio is 300 over 500, which is then just 3/5. Okay. What's our first term? 500 here. So then the sum, and notice here it just has a dot, dot, dot. That means it keeps going forever, right? And so we're going to find the sum of 500 divided by 1 minus 3/5. Okay, I guess I should have paused real quick. If our common ratio is 3/5, is that less than 1? Is the absolute value of that less than 1? Yes. So this does qualify as a finite sum. We should be able to find a sum of this infinite geometric series. So let's do that here. So it'll be 500 over 2/5, which is the same thing as saying 500 times 5/2. Right, instead of dividing by 2/5, you can multiply by the reciprocal of 5/2 there. And then let's see here, 502 can simplify to 250 and 5. So let's see here, 25 times 5 is 125. So 250 times 5 would be 1,250. Okay. And so there it is. There's your sum. You're adding up an infinite number of things as a finite value. Okay. All right, you guys try this one, and then we'll be done. The sum from n equals 1 to infinity. So notice here, right, we put a little infinity symbol up there. So we're going to add up an infinite number of terms. Okay? So that's your clue. There's an infinite, series here. Okay? So go ahead, find that sum. Find that sum. Believe it or not, this is a problem that you may run across in calculus. Okay? You may see something just like this. You'll definitely be using this formula in calculus. Okay, in the BC part of calculus, if you take ABBC. If you take AB, you won't be running across this formula. But if you take ABBC, you'll see this formula again. It will make a reappearance. Oof. Should have picked a better number. Oh well. Does this sum qualify for our infinite geometric series formula? Can we use the infinite geometric series formula for this? Well, we're adding up to infinity, right? So it is an infinite sum we're trying to find here. Is our common, what's our common ratio in this problem? It's going to be -1/2. Yes. Okay. You can see it right here, right? That -1/2 is in parentheses, and that's the exponent of that is changing, right? It's increasing for each term, and so it's going to be repeatedly multiplied by -1/2. Does that qualify then for our formula here? Does -1/2 qualify this? Does that make it true? Yes. Absolute value of -1/2 is less than 1, so we can use this formula. Our first term is 1,000, divided by the quantity 1 minus -1/2, which gets you that when you round. 666.666666666 repeating. Okay? So on and so forth there. Yeah. Okay, so there's our answer. Questions on any of that? Alright. Some of you guys are like, aha, I knew these summations were satanic, and now Mr. Wood has proved it. Okay, so there you go. Alright, so your assignment. Your assignment. Get that for you here somewhere. Ah, it's hiding. Okay, page 667, 7 to 19, 23, 35, 37, 45, 49. I know this is going to be like a weird smattering of problems here. I need to stop? Alright, I'll stop. Okay, and again, you may use calculators for this too. Okay. Yes. Yes. Oh, you know what? I may have. Let me see here.
Maybe I can't save this for second time, guys.
Yeah. Gotcha. Thank you. Okay, I do have a problem, not the problem set, well I do have a problem set, I'm going to get to that in just a second. But I also have a review for you. I do have the review for you here. So I've got a copy, so you can start looking at that.
Thank you. How did you get a good grade on that? I have a 70. I got an 80 test.
ran out of review sheets, so I'll have to get you more tomorrow. Okay. Yes. Yes. And then I have the next problem set for us too. Due Monday. That was the review sheet for the test. Yep, this is the problem set due Monday. Due Monday. Okay, nice practice with your log sines, log cosines.
Oh, I thought that was I thought the whole trigonometry thing was done.
What's that? Did you do the homework yet?
It's not bad. I'm so
Well, you'll see. Some of them are just like, is it a geometric sequence or no? You know.
better be like half of them. That's a lot of problems.
Well, it's not due till Monday. And you guys are going to come in for set, right?
The roughest week of my life.
Why is that?
Because today I won't get home until 10. Tomorrow I won't get home until 9. Thursday I won't get home until 9. And
Ew.
Friday I won't get home until 9.
Is that all lacrosse related?
We have scavenger hunt and team dinner tonight.
Well, you can't skip that.
And then tomorrow we have our first playoff game. And then Thursday we have a late practice because Coach Dave has to take his daughter to the hospital. Yeah. And then Friday we have another playoff game, so they'll be ready for second.
I gotcha.
Can you pull me into set today?
Yes, I will make sure to put you in. Grace, you too still?
Everything in my body hurts. It's fine. I'm fine.
If you want to stop by at the end of the day, I will have more review sheets available too. So if you want to stop by at the end of the day, I will have more review sheets available.
So is this thing on Thursday?
Thursday.
Test.
Test. Bye guys, have a good day.
Because there's no graphing.
Yeah, but it does have like the trig equations on it, which gave some people some trouble. So, we'll see ya. Morning, how are you? Good.